Hey, welcome to T8 Maker Channel. If you watch my other videos, thanks for coming back. If you're new here, welcome. Hope you enjoy this video, and there's plenty more videos like it on this channel. Either way, if you're one of the 90% of people who've watched these videos and aren't subscribed, please consider subscribing. It doesn't cost you anything and it really helps get the channel out and it encourages YouTube to recommend this channel to more people. And thank you for the support. So in today's video we're going to look at Bambu Lab's carbon fiber filaments. So we're going to concentrate on this video on the actual outcome of the prints, what they look like, how they feel, etc. and my recommendations. And then in future videos we'll take a look at the individual filaments. I hope you find this useful. Let's get started. So here we have each of the prints. We have our Jayo PLA+, Prusa PETG, PLA-CF, PETG-CF, PET-CF, PAHT-CF, and then we have the eSun, which is a nylon carbon fiber. So this one is before drying and this one is after drying. So we have a full range to compare. These four are the four from Bambu Labs. This is eSun, Prusa, Jayo. So hopefully what this will give us is some comparison between each of them. So first up we got PLA from Jayo. This is a PLA plus. It's $15.99 plus tax for 650 grams, so works out about $24.60 for a kilo at that particular price. It's a 1.75 with a plus or minus 0.02 accuracy. As we can see, when trying to loosen up, it's very, very stiff. It doesn't open or close too easy. This part doesn't twist at all. And we have breakage here when I try to loosen them off. So it doesn't appear great for this particular print. So for the vice grips, it's a little bit brittle and doesn't really hold well. For the Catapult came out pretty good. So we got a little target. That came out fine. The springs are good. The fittings are good. It's generally fitting well. And it's pretty solid. So it's okay. It's good for these small little toys. But for anything mechanical, probably not so good. Prints nicely. It's got good dimensional stability, so it is pretty close. It's got good detail, but it is a little brittle, just like all PLAs. The vice grips came in at 50.75 grams and the Catapult came in at 33.6 grams. Next up, we got Prusa PETG. So Prusa PETG is about $24.38 plus tax for 1 kilo. It's a 1.75 with a plus or minus 0.02 dimensional accuracy. If we take a look at the parts, the vice grips is fully operational. No issues. We can see a tiny bit of stringing here. So it does string, but that's not a bad print. Fairly stable, fairly steady. I wouldn't remove nuts with it, but it's pretty good. The Catapult, the target, it's clean. This is just some support that needs to be removed. The mechanism itself, the springs, all work good, no issues. Now we do have some black burning mark. There is more in there, I do see this quite often with Prusa PETG. Don't know what causes it. I'm sure there's an expert out there who could tell me what to do, but it's probably some kind of a temperature issue or a flow issue. But I do see this blacking burn marks on the Prusa PETG. But overall, prints are nice, they're clean. You know, occasionally that burning, but overall good dimensional stability. Vice grips came in at 50.35 grams, and the Catapult came in at 33.31 grams. So very close to the PLA, just slightly lighter. Next up, the carbon fibers. We're going to start off with the PLA. So everything works on this as far as the mechanism, but the adjuster doesn't work, and I know if I twist this, it's just going to break off. So it's a little bit soft, unlike this one here. This one's seized as well. There's no give in this at all. It is just solidly seized. So that was the Jayo PLA. This, on the other hand, is very soft, and as you see, it just twisted off. It's not really held well. The other thing as well is we have a bit of a print issue here. So this is not good, but where it has printed well, the finish is nice, it's smooth, but it does feel very soft. I feel I could break this very easily, relatively easily. So you probably don't want to do anything that you want strength in. It's not very strong, and again, for these print in place parts, not great. Let me come to the Catapult. So I've had two issues with the Catapult. One is my own fault. So we have the target. Target looks good. We have the body. Springs are good, but we are missing one of the pieces. Obviously I lost it during the printing process when I was taking it all apart. But we also have, when I was putting on here, this piece broke off. So we obviously, again, we have issues with strength. It's not very strong, but it does have elasticity. It does bend and twist. So depending on how you print it and what infill you get, you're going to get mixed results, but overall it's generally softer than the PLA. So unless you really need carbon fiber, or there's something really about the carbon fiber look you really want, I don't think it's worth the money. I don't think it's worth the extra expense in order to get it. It looks nice, but that's it. So if we just go through its issues, and actually I can see another as I look at it. I didn't notice this previously. I don't know if you can see that. We have some bad print here as well. So, and that's with Bambu Lab's profiles for those particular carbon fiber filaments. So you would expect the best possible print on a Bambu Lab printer with Bambu Lab profiles and Bambu Lab filament, but it's not that way. So this is PLA-CF Gene Blue. It's $34.99 plus tax for 1 kilo. It's a 1.75 again with 0.03 millimeter dimensional accuracy. It's a carbon fiber infill at 5 to 10%, and it's supposed to print in a matte color, which I think it does. It's pretty matte. So their claims, it's got improved strength, It prints with regular PLA. It's got low shrinkage. It's not prone to clogging, and it has an RFID for the AMS to identify it in the AMS, which is quite handy. It's very useful. My thoughts on it: the parts are not as precise as I would like them to be. The prints look nice, but they're flimsy. It's good dimensions and nice finish, and adds an option for aesthetics, but in my view it's not worth the extra cost over the normal PLA. It's 6 to 10 euros or dollars more, and the consistency is not as good as others. So that diameter consistency of 0.3, it's not as good as 0.02. It's not going to make a huge difference, but it's obviously not as accurate. So that's the PLA-CF. Not a recommendation. Next we move on to PETG-CF, and PETG being my favorite filament outside of ASA. This should be comparable to the Prusa PETG. We should see better results. We should see a nicer print. But do we? So first things first, we'll take a look at the vice grips. So vice grips move just as you expect, same as the Prusa. We have stringing. Not sure if you can see that, but there is some stringing in here. Maybe there. But we do have a little bit of stringing in there. But other than that, works perfectly. No issue. It's got a nice finish. Didn't have to use glue, so the finish looks good. Onto the Catapult. The target is good. It's exactly what you want. Has a little bit of give in it, so it's not going to break so easy. Springs are good. Nice strong reflex on the springs. We have a nice finish here. Generally good all round. Very nice. Like it. Is it better than the Prusa PETG, which is about $10 cheaper? Nope. And it's supposed to be shiny. It actually comes up matte. Don't ask me why. But it's definitely not any better than the Prusa PETG. Really don't see the need for spending the extra money. It's fine, it works, it's brilliant, it looks good, but I just don't see the reason to spend extra money. So let's just go through the stats on it. So again, this is $34.99 plus tax for 1 kilo. It's got a dimensional accuracy of 0.03 again. Again, it's a carbon infill of 5 to 10%, so there's very little carbon in there. It's supposed to be shiny, but it's definitely not. It's got a drying of 65 degrees for 8 hours, and I forgot to mention this is 55 degrees for 8 hours. In my particular case, I didn't give it that long to dry. I gave it probably 4 or 5 hours. So maybe I should give it more, and maybe if I give it more it'll be better, but I think the PETG is fine. Obviously this is brittle, so maybe this would be better if it had more drying, but I just want to be realistic. Most people won't give it that 5 to 8 hours, so I gave it about 5 hours. That should be more than enough. So their claims, so less clumping and stringing, I would agree with that. There is no clumping and stringing. It's got a carbon fiber texture, yes, but not massively. It's got a shiny finish, it definitely doesn't. It's highly flexible, it is flexible, and the RFID for the AMS, which is pretty good. So overall, my thoughts is it is bendy, but as with everything, it breaks. It's got nice layering. It's got a nice smooth feel. The prints are precise, but they're not shiny. Overall great, but again, yeah, it's not worth the premium. Don't know why you would want to do that. So as far as weights, we got the vice grips are 46.7 grams and the Catapult is 30.8 grams. So that's 47 versus 49 and 30.8 versus 32.18. Next up, the two expensive ones. So these are very expensive filaments and you would expect to get a lot for your money. So they're generally they're not aimed at toys or art or anything like that. These are specifically aimed at more engineering parts. If you wanted to print replacement parts for your car, you know, plastic parts that are high temperature resistant, so up to 200-ish degrees according to their website. So these would be the ones for you. They are supposed to be very strong, robust, and print nicely. So let's just go through them. So we'll start off with the PETG. So PETG is the one that you cannot print in the AMS, so do not put it in your AMS. It's a very stiff filament. It will just snap in the tubing, and then you're going to have to dig through the tubing and try and pull it out. So don't print it in the AMS. You print it separately, print it outside, or print it on the like I did on a pair of rollers outside the printer, so that it's able to get a nice long curve into the printer. I did try to print it inside a heater, inside a dryer, with a PTFE tube leading into the printer, but it just broken the PTFE tube, so don't do that. Okay, so for PETG-CF, let's take a look at the parts. First up, we've got the vice grips. Very nice look to it. Very abrasive. This is like sandpaper. It's very harsh to the touch. When these print, they print with a brim by default, and the result of that can be a very difficult print to, especially if it's a print in place like this, it can be very difficult to get it going. And as you can see, this thing is effectively useless. It's a paperweight. Nothing on it moves. I can squeeze as hard as I like. That's the best I'll get. So I've moved this one and this one, but this is still rigid solid. So, and short of putting a hammer to it, I don't see me moving that. I definitely do not see us adjusting the head or the mouth. This screw is printed solid. It's just stuck together. It's not going to move ever. So good solid piece. As you can see, I put a lot of force on there. It's very strong, very, very strong. So from a strength perspective, really good, really solid stuff. And I printed in PET before, and I've had a hit and miss luck with it. It can be brittle sometimes. Go figure. Then we come to this side. So this printed fine, no issues. But the little stands just tore apart. They were too thin, and when I tried to squeeze them over, they just came apart. So there's very little strength in them. This is good and solid. And the springs are by far the most elastic and resistive. I mean, this is ideal for a catapult. It really, really does move. It's actually easy enough to put together as well, and fairly robust. So this is a pretty good print. I like this. So this is a much more expensive filament, but I can definitely see where there's a use case for this. The PET-CF. This one here is $84.99 plus tax for 1 kilo. It's 1.75, 0.03. They're all 0.03. It's a PET and carbon fiber mix with 12 to 20% carbon fiber. Its drying is 80 degrees for 8 to 12 hours. Do not put it in the AMS, it is extremely stiff. So the claims from the website: low moisture absorption, so that's for the printed part, high dimensional stability, and exceptional thermal resistance, so around 226 degrees C. Now, when they say, as I say, no low moisture absorption, they mean this part, not the filament. The filament will absolutely absorb water, and it will print with bubbles and strings in a mess if you don't dry it. So dry it before you print. It's expensive stuff. You don't want to waste it, and you don't want to have to redo your prints just because it got a bit damp or you didn't dry it long enough. So give it a good long dry. So my thoughts on it: it's very stiff, nice print, low warping. It's no good for these fine dimensional prints. It doesn't seem to be too good at that, although it did actually break and crack open on this side. But for these particular screws, it's just solid. So no print in place parts, I would say. It's tough, but you could probably break it with hand force if you put your mind to it. You certainly can the smaller parts, but as you can see with the bigger parts, you can put a lot of force on it before it'll break. And the other thing as well is, and I hate this, it needs glue in order to bond to the print table. So if you don't put glue down, it's not going to bond, and the glue is horrible, and I hate it. And yeah, so if you don't like glue, stay away from it. Next up, PAHT-CF. So this is a nylon. So this is a PA12 with some other long chain PA nylon along with carbon fiber. So let's take a look at the parts. We'll take a look at the vice grip, and we'll take a look at the catapult. So vice grip, you have some good dimensional movement here, although this part, like this one, is seized solid. So quite a lot of pressure there, no movement. This part here is definitely not turning, but it did break off. So it doesn't appear as strong as this one, but it's pretty tough. I mean, it's not the weakest one I've ever come across. The print is nice. It's not as abrasive as this one, but again, the screw is solid seized. Some of the mechanical parts printed okay, but other parts really didn't. So the catapult, again, target printed well, no issues with the target. Springs are good, nice and clean, no messing. Good fit, went together well, and reasonably strong elasticity. Overall, nice parts, no issues, dimensionally looks good, and overall fairly easy to print as long as you follow the rules. So this is by far the most expensive of all of the filaments on this table here. So this is $94.99 plus tax for 1 kilo. Again, 0.03 dimensionality on a 1.75. It's as I say, PA12 with other long fiber nylons or long chain nylons. It's also got carbon fiber in it between 12 and 20%. Its drying time is 80 degrees, 8 to 12 hours, same as this one. This can be used in the AMS, and I did print this in the AMS without any issues, so pretty good. So its claims are low water absorption on the parts, same as this one. Exceptional Z bonding, so, and layer adhesion. So it's saying that the layers stick well. They do, so I can't argue with that. High tensile strength, yep, pretty good. And high temperature resistance, I think it's around just over 200 degrees, and an RFID for the AMS. So yeah, this is pretty good stuff. But my thoughts: strong prints, good elasticity, not great for print in place, but a nice finish. So is it worth 100 for a kilo? It depends. It depends greatly. I mean, if you're printing toys like this, no, it's absolutely not worth it, and don't waste your money. But if you're printing a mechanical part for a car, a replacement plastic part for a car, or you're replacing a mechanical nylon part, this is good stuff. This can do it, and it can definitely do it, and it can do it in some harsh environments. So it's well worth a consideration if it's worth it to you. So if you have to spend a couple of £100 to replace some plastic part, but you can print it for, you know, under 100, then why not? So definitely an engineering printing tool, not a toy, not for playing around with. So this one came in at 42.88 grams, and this at 28.58, so it's lighter than these ones down here, and it's also lighter than the PETG. So PETG is 55 versus 42 for the vice grips, and 38 versus 28 for the Catapult. So this is also very light, much lighter, and you can feel it. It's significantly lighter. Last up, and I'll do these together because there's no point in wasting too much time on it. It's exactly the same filament. So I bought a roll from Amazon of eSun PLA-CF. So this is a carbon fiber nylon, supposedly, according to their website, 25% carbon fiber. It could very well be. I haven't checked it, so I don't know. It's $48.10 plus tax for 1 kilo, which is a great price. So it's nearly half the price of this one and this one, and it's got a 0.02 dimensional accuracy, although question that, but you know, it should do. This does smell when it prints, so the smell on this is quite unpleasant. If you open the door and you take a whiff, I would keep the door closed. These not so bad. Jayo is always a little bit funny. I actually love the smell of this stuff. It's probably a bad thing, but this stuff always smells pretty good. So I don't know what they use or why it smells okay, but for me personally, I think this smells okay. Not an issue with it. These can be slightly chemically smelling. These are really chemical smelling. So if you don't like printing ABS, you're probably not going to be like these. They're not as bad as ABS, but they're not pleasant. So I found this very difficult to work with. So this one was not dried, this one was dried. I found that neither of them sat on the print bed well, but the damp one sat on the print bed better and stayed there. I threw out multiples of prints of this when it was dried, and I tried to print it on exactly the same print bed with exactly the same settings and exactly the same details, and it just kept moving around, kept catching the head and falling off the print bed. So it's very difficult to work with. It's brittle, as you can see. It just, especially as wet, it just broke apart, and even as dry, you know, just snaps. So to me, it's got poor dimensional stability. Wasn't able to get any of these devices working. And just look at that. I mean, just seriously, look at that. This one here is it's a 50% fill. Just look at the bending. I don't know what the story is with that. It got tangled. There was stringing, and you can see it all over the place. Yeah, it's not very good. Print quality is average to poor, and you might fare better with a custom profile. I actually used the profile from eSun, so I went onto their website and downloaded their profile. I also tried a custom profile myself. I also tried printing this on a Prusa as well as the Bambu Labs, and every single time it was a disaster. So yeah, my view, don't waste your money on this. It's cheap. Feels like it's cheap for a reason, but you know, your mileage may vary. So for the 50 infill, the vice grips was 56.81 grams and the Catapult was 31.8 grams. And for the 25% fill, it was 47.51 grams for the vice grips and 31.25 grams for the Catapult. So as you can see, just looking at this, the Catapult, when I try to put it together, just disaster. Nothing fit and everything broke. So pieces just broke off. This piece broke off. So you can see it's just, it is crap. This is just very soft and very bendy, and there's really no stability in it whatsoever. It's just not going to waste any more time in it. It's, in my view, it's just junk. It's just rubbish. It's landfill. So that's all of the filaments and all of the prints that I did, and that's the results of what I've seen. So final thoughts and ratings. eSun, it's junk. Don't even waste your time with it. Don't use it. Don't spend money on it. Yeah, you can give it a try if you want to. It's not that expensive, but ultimately at the end of the day, it's still money. And if you want to get something useful out of it, then it's probably not the filament for you. So forget about the eSun. Jayo. So I've had mixed results with Jayo. Jayo is I think it's a brand of eSun, to be honest. I mean, I'm not 100% sure, but I think I've heard somebody say that they are a sub-brand of eSun. I have had mixed results with Jayo materials. Even their ABS, I had a whole batch of their ABS. So I had 8 by 650 gram rolls of their ABS, and depending on the color you printed with, some of them just would fall apart. So I don't know if it's the coloring they use in the filament or what it is, but it's a real hit and miss. The black ABS was pretty good, but everything else was almost junk. I've also, I mean, they can be very cheap. They can, but also if you buy them one reel at a time, they can actually be far more expensive than brands like Prusa. So why would you spend more money to get less quality? So a kilo of this is dearer than a kilo of Prusa. So, or you know, pick your poison. Doesn't really matter which one. So Jayo as a brand is not really dependable, but I had this reel of Jayo filament PLA plus, which is supposed to be extra strong, and to be honest with you, it's junk. So I can't really determine that PLA is bad for this, but this Jayo filament is rubbish. So too expensive, doesn't work really well. So that leaves us with these 4 carbon fibers and a Prusa PETG. Yep, for me this is a winner through and through and through as far as filaments go, because it's stable, I have no issues with it. Everything I do with it works. Never had any problems with it, and it's far cheaper than the carbon fibers. So I think after tax and shipping, I think it was like 140 quid for 5 rolls. So that's what, about 30 quid a roll. So maybe dearer than the Jayo before tax, but after tax, so that included tax and shipping. So when you add tax and shipping on, it'd still be cheaper than that, but the quality is just, it's miles better. Is it the best? Don't know. Are they better? Probably. So, you know, your mileage may vary. In Europe, Prusa is pretty darn good. You can't argue with it. So my recommendation is, if you were thinking of buying these here and you're in Europe, I would consider Prusa instead. I wouldn't really spend the extra money on these, or just get the standard PLAs and the standard PETG from Bambu Lab, although I haven't tested it. So as far as these go, so PLA, issues with the printing, issues with the mechanics and the strength. Looks nice. If you want to build a statue or print a model that looks nice and has some nice sort of no layers and looks good, then go ahead. But it's, you're talking about 10 euros, $10 more than, you know, a PLA or a PETG. So, but if you want a standard PLA for carbon fiber PLA, then I would go with that. So I would rule that one out. PETG-CF, I think it's pretty nice. I like it. It works well. No issues with it. Everything is mechanically good. Everything looks good. Probably prints slightly better than the Prusa. So, I mean, definitely. But is it worth 10 euros, $10 more than the Prusa? Probably not. So I would probably still go with the Prusa. Although I do like this. If I had a roll lying around, I wouldn't be sad about it. But it's certainly not something I'll be racing out to buy again. Not at the price that it's at. So from that perspective, it's a no-no. Then we go to PETG. The PETG, very good. Really like it if you're using it for the right reason. So, and the right reason is not this vice grips. This is not a good way to use it, but this is super strong, really robust, nice print quality. You know, okay, yeah, these little things broke, but you know, don't make delicate stuff with it. Make good solid stuff with it and you'll be a very happy person. I wouldn't like to get caught in that catapult. The strength in that thing, maybe I can use it to get rid of some of these pieces, but yeah. So this one here at $80+ a roll, I would definitely keep a roll around. If you need to make things that are really strong, really robust, this is your stuff. I would definitely have a roll of that. A lot of money, but 500 gram roll, keep it there. Anything you have that's, you need it to be strong, you need it to be robust, you need it to be resilient and heat resistant, definitely. PAHT, again, I reckon you could actually make mechanical parts on this, but you're going to have to make them separately, not as a print in place. And I think you could make a really good pair of vice grips with this, just like with this one. But it would have to be printed in parts. It is really, really good, really strong. Yeah, I broke this off. It's not as strong as the PET, but that may have just been one bad piece, because but I can't bend that thing at all. I can't move it. It's really solid. And this part, it's dimensionally accurate, it looks good, feels good. I think that's brilliant. These two, I would definitely keep a roll. I wouldn't go out buying a couple of rolls of them. I wouldn't have kilos of it lying around, but I would definitely buy those for very small use cases where I need something really, really strong. I would also consider, though, if I was going to go down that road, that I would also consider maybe Prusa ASA or some other ASA, because I found that's also very strong, although it did break down in layers when I took a hammer to it. These here, I think I'd be hard pressed to break these down. So with that said, that's my assessment of the filaments. In short, can't really comment on the Jayo PLA. I think it's Jayo, so I'm not going to say anything. The eSun, same thing. The Bambu Labs PLA-CF really only has a very limited use case, and it's only for aesthetics. It's only if you want something that looks a particular way and you need it to look that way, get that PLA. The PETG, if you've got a roll lying around or you're feeling flush and you want to add a roll, absolutely, definitely I would add a roll. It would give you a new look, a different type of print, but it's not really any better than this. So why would you spend more money? If all you want is this, why would you spend money on this? So, I mean, there's no difference. They're pretty much identical. I just absolutely no reason that I can think of to spend the money on the carbon fiber PETG. Just no reason. Cheaper ways to do it. Thanks for watching all the way to the end. That was a longer video than expected, so you're an absolute legend to go all the way to the end. If you enjoy this channel, if you enjoy the video, please like, share, comment and subscribe. Really helps the channel to grow, won't cost you a thing, and it will allow me to get more videos out and to get more videos out to more people. Thanks again. Bye.